Egypt. History stretching back for millennia. The emergence into the third millennium is affecting all walks of life. El Dikela, in the extensive industrial belt of Alexandria. This is the home of the country's largest steel producer, the Alexandria National Iron and Steel Company, ANSDK. Initially specializing in the manufacture of long products, the company succeeded in the year 2000 in making its entry onto the market for flat products with a CSP plant for ultra-thin hot strip. Modern plant technology from SMS Demag for the manufacture of thin and ultra-thin hot strip. The casting, rolling of thin slabs in a CSP plant. A continuous, energy-saving process. Directly reduced iron pellets, DRI, serve as the charge material in the steelworks, with a proportion of up to 90%. Steel is made in the electric arc furnace and in the ladle heating furnace, providing a wide spectrum of carbon steel grades. That is, steel of the highest cleanliness for a high-grade hot strip product. In the first process step, the continuous CSP plant casts thin slabs of 52 millimeters thickness. These are then homogenized in a roller hearth furnace, followed by rolling out to hot strip while in the same heat. Casting with long sequences involving up to 6 successive heats. High productivity for an annual output of 1 million metric tons. This CSP plant set standards right from the beginning. Successful commissioning after a construction period of only 22 months. Production of hot strip of 1 millimeter thickness after only 6 months. Consistent further utilization for thin and ultra-thin hot strip. An essential prerequisite for the above achievements, utilization of the most up-to-date automation from SMS Demag, with Level 1 for the technological control systems, and Level 2 for the process models. The personnel had already received the relevant in-depth training on comparable facilities. The peripheral facilities of the plant are utilized optimally. The workshops for conditioning of the tundishes, molds, and segments are perfectly organized and can be reached rapidly from the casting floor. The entire CSP plant is supported on stands 5 meters above the floor. This proved to be most advantageous when organizing the layout of the utilities and operating facilities, and is also practical for the logistical aspects. Back to the casting machine. The CSP mold, patented worldwide, and having a shape which funnels upwards to promote good flow conditions, is the crucial element in thin slab technology. Preparations for the next casting sequence. Tundish being traversed. Ladle being brought into casting position. And the automatic casting process starts. A virtual view into the casting machine demonstrates the sequences. The dummy bar is raised. The tundish is filled, and then the mold. The dummy bar is disconnected and the casting strand starts to bend. Straightening and withdrawal. Cropping and cross-cutting. The thin slab strand has meanwhile reached the exit end. Strand thickness is 52 millimeters. Crack-free surfaces with low scale formation. This is CSP quality. Cutting up into the desired lengths initiates the second process step in the continuous CSP process, which is the temperature homogenization of the thin slabs in the roller hearth furnace. The roller hearth furnace is 185 meters in length, is heated by natural gas, and has been supplied by the Italian firm of Tecient Intalimpianti within the consortium. The furnace also acts as a buffer while the work rolls are being changed in the hot strip mill, a process which takes only a few minutes. Irrespective of the holding time in the furnace, the strand exits at a constant temperature that is in harmony with the shaping conditions in the rolling mill. The surfaces are descaled prior to the initial pass in the hot strip finishing mill. This is followed by the thin slab being rolled out into hot strip, that is the third step in the continuous CSP process. Reduction to final thicknesses of 1 to 13 millimeters and to strip widths of 900 to 1600 millimeters. The quality requirements made on the hot strip product likewise place the strictest requirements on the automation systems at level 1 and level 2. The technological process model developed by SMS-DEMAG for pass schedule calculation and mill setup determines online all of the set point values needed for the downstream control systems. The gauge control concept comprises the hydraulic roll gap setting system, AGC roll gap control, dynamic disturbance compensation, and monitoring. A stable mass flow in the rolling mill is ensured by highly dynamic loopers between the stands in conjunction with optimized drive controls and by roll gap lubrication in stands 3 and 4. CVC technology and work roll bending form the core of the automatic profile and flatness control. Feedback, the rolling results determined by the measuring devices in the exit section, are fed back to the process control system. Closed-loop control systems for the desired finished strip geometry. ANSDK is thus able to make consistent use of the plant for the production of thin and ultra-thin strip. Changing the work rolls. The proven quick change system requires only about 8 minutes. Casting can meanwhile continue upstream without need to reduce the speed. The roll shop is situated at the side of the plant. Here the work rolls are given the typical CVC crown. The roll sets are pre-assembled ready for installation. Modern technology at the motor side. The total installed electrical power is approximately 47,000 kilowatts. It transmits the required rolling forces of 32 to 42 meganewton onto the stands. The electrical system for the drives has been supplied by Siemens AG within the consortium. The laminar flow cooling section, with its narrow roller spacing, it even transports ultra-thin strip in a gentle manner. The water supply is purposefully structured section by section for precise achievement of the strip properties. The SMS-DEMAG process model for the laminar flow cooling ensures constant, reproducible product quality. The optimized laminar flow cooling system additionally improves the strip quality by means of an edge masking system. Water is a valuable resource requiring careful treatment. The service water is semi-cleaned in a complex water supply and treatment system, filtered, cooled, and then fed back to the CSP plant. To conclude the 3-stage CSP process, the finished hot strip is fed into the universal downcoiler, where it is wound into compact coils. Reliable functions of the computer-controlled snubber roll system at coiling speeds of up to 15 meters per second and coil weights up to about 29 metric tons. Step control for the winding of initial wraps acting gently on the strip. Compression points on the strip are avoided by raising the snubber rolls when the strip head passes through. The universal coiler has no problems with winding the entire range of hot strip from 1 to 13 millimeters thickness into coils of up to 2,000 millimeters outside diameter. Discharging and transfer to the coil transport system. Top quality is required for further processing of the hot strip. This is secured on a permanent basis with the aid of random checking. Thorough tests are performed in the works laboratory to confirm the material properties. All in good order. For transport, the coils are banded with steel strip. As a final act, the marking releases the coils for sale or for further processing at ANSDK. For the latter, SMS-DEMAG has supplied a pickling line and a temper mill stand. CSP hot strip has an excellent reputation among the further processing firms. It is cost-effective, it has the best tolerance values, and precisely defined material properties, providing ANSDK with a sound basis for entering a demanding market.